2.3 Day 5 notes. We're talking about piecewise functions. Piecewise functions. So let's think about that word for a second. Piece, meaning parts of a graph. Wise, meaning it's composed. So it's a graph that's composed of different pieces. And let's get the definition here. So they use different formulas or equations on different parts of its domain. So it's got different pieces. Could be like a parabola or a line or a square root graph, and it's defined on different parts of its domain. So maybe from 2 to 7 it's a line, and then from 7 to infinity it's a parabola. Okay, so let's start with a little graph here. I just have the positive axes with tick marks here. So go from 1, 2, 3, 4, 5, 6 on the x-axis, and 1, 2, 3, 4, 5, 6 on the y-axis. So 6 on both axes. And I got a point here at 2, 4. So that points at 2, 4. Okay, so then here's my first piece of the graph. You should recognize that. It's a parabola. So I started at point 2, 4, and I made the parabola through the origin and then back off to this side, and it's symmetric around the y-axis. Okay, and then my next piece here, I'm going to make a line. So I started at 2, 4, and I went through the x-intercept is 6, 0. So those are the 2 points you should have, 2, 4, and 6, 0. Okay, so then what's the equation for this weird, goofy function? We know it's half line, half parabola. What's the equation for it? Okay, well, here's how we write it. F of x equals, then we have this big set, this big bracket, squiggly bracket. Get a little practice making those things. Because it has two pieces. I'm going to write the first piece here and the second piece here. So you know it has a parabola, that's part of it, and that's just x squared. So one part is just x squared. But then the question is, what's the domain for that x squared piece? So it looks like it goes from negative infinity up to 2. So the parabola is only alive or existing on this graph from negative infinity up to 2 on the domain. So we'll write that as x less than or equal to 2. So for the parabola, it's only around for x less than or equal to 2. That's the domain for that. I didn't ask about the range, just the domain. And then the line, well, you could come up with this line. Now that I've given you the 2 points, you could come up with the equation of this line. But for now, I'll give you the line. That's negative x plus 6. Negative x plus 6. So then what's the domain for this guy? The parabola is everything from 2 and on down. So for the line, that looks like everything above 2. So let's, everything above 2. And let's be really clear here. 2 is only included on one of these graphs, right? To be a function, you have to pass the vertical line test. If these points were both included here, it wouldn't pass this vertical line right here. It would almost be like we had overlapping dots. It would count twice. So to be clear, x squared for everything up to 2, and then everything beyond 2, we're going to use the line. So this is our first piecewise function. It's composed of these two pieces. These are our parts for our graph. And then these pieces over here, that's the domain. So x less than or equal to 2, x greater than 2, that's talking about the domain where these graphs exist. Okay, so example 1. I'm going to give you a piecewise function. In fact, it's got 3 pieces. So x minus 5 for when x is less than or equal to 3. 1 for x is between 3 and 5. And then x plus 1 for x is greater than or equal to 5. Oh, green hand, green hand, green hand. There we go. That's what I wanted. Okay, so how do we graph this? Well, let's start with the axes. So I'm going to go on the x-axis out to 1, 2, 3, 4, 5, 6, 7, 8 on the x-axis. And then 1, 2, 3, 4, 5, 6, 7, 8 on the y-axis. And then on the below here on the y-axis, I only need negative 1, 2, 3, 4, 5. So only down to negative 5. So I'll just add those in for the scales. 8 on the x-axis, then positive 8 down to negative 5 on the y-axis. And I've got a tick mark for each one unit. Okay, so let's start making this graph. You've got x minus 5 for x less than or equal to 3. So if you look what I've wrote out here, this is my thought. My thought is that, well, that's really just a line. That's like y equals x minus 5. We can graph that line pretty easily. It's got an x-intercept of negative 5 and a slope of 1. So let's add those points to our graph. I want to be specific here because I want to see where these graphs intersect, so I'm going to make the dots for this. So x-intercepts negative 5, and then the slope's 1, so it goes up 1 each time, and then there's my line. Okay, and you'll see I drew a dotted line in here, because that's where I'm going to cut it off. So I'm only going to use that line, that x minus 5, I'm only going to use that for values less than or equal to 3 for the x. So when I get up to 3, I'm going to cut the line off right here. So essentially I just made this first line, y equals x minus 5, and then I just erase the stuff I don't need. So now we've got it down to just the piece we want. I know I have this dotted line in here, that's just for reference, so I can see where I need to cut that line off. X equals 3, that's where it's getting deleted. Okay, next piece we need, 1. How do you graph this? 1. Well, if it's f of x equals 1, that's really just like y equals 1. So y equals 1, that's reasonable, we can handle that. I mean, that's just a line here. Go to 1 on the y-axis and draw a horizontal line. But again, since this is the piecewise function, we only want that line to exist between 3 and 5 for the x values. So that should give you a clue as to where we're going to chop this line off. Since I only want it for x's 3 and 5, so I'll give myself a little reference point here between 3 and 5. I'll erase all the other stuff. Now, my endpoints, it looks like it's not included at either one. So I'm going to just draw open dots here, open circles at 3 and 5. Because the last line, that was included at 3, so I got a closed circle. This one between 3 and 5 is not included at the endpoints. Those are both open circles. Okay, so that's our two of our 3 pieces down. Notice I'm color coding these two. 2 of our 3 pieces are done. How about the last one here, x plus 1? That's also pretty simple. That's just a line, right? You can write that as y equals x plus 1. Just write it that way. And then let's go ahead and graph y equals x plus 1 here in green. So y-intercept's 1, and the slope's 1, so I try to be kind of accurate, and I put these points down. And I drew the line through it. Okay, and again, we need to figure out where we're going to erase this line at. Where are we going to chop this line off? Because we only need it for x greater than or equal to 5. So, I'm going to go up to 5 here. I'm going to erase all the other stuff that I don't want. And then this one does get a closed circle right here. So that does get a closed circle. So that is actually our completed piecewise function on the graph. It's composed of 3 pieces. They're all in different parts of the domain. And by the way, it's still technically a function. If you did a vertical line test for any of these points, it would still only hit once. So even though they're overlapping, they're in different spots, it would still only hit once. Like say I drew a vertical line through here, it only hits the graph once right there. I drew a vertical line through here, it only hits the graph once right there. So this still passes the vertical line test, so it's a valid function. Erase these vertical lines. So that's our first piecewise function graph. Okay, now I just have a couple questions about this graph for you. First question, what's f of negative 1 equal? So you've got the graph here, and you've got the equations. First of all, where is it appropriate to plug negative 1 into? Which graph? Well, based on the domain, negative 1 for an x value would be over here. So in the red, negative 1 is only appropriate to plug into x minus 5. So let's be clear about that. If I'm going to plug this value in, I got to know where to plug it in. So that's got to go into the red, looks like x minus 5. It's got to go in there. So f of negative 1 looks like it'd be down here somewhere. So if you evaluate it, plug in negative 1 here. Should be at negative 6. So f of negative 1 equals negative 6. Okay, how about f of 3? So you got to find a specific place to plug 3 in. If I look at the graph, 1, 2, 3, it wouldn't be right to plug it into the purple line here because it's not included at 3. So again, it'd be good to go to the red. That one's got a closed out at 3. So what is that? The coordinates of that would be 3, 2, it looks like. Or just plug it in up here, the red line. So for x less than or equal to 3, plug 3 in for the x. So 3 minus 5 gets us negative 2. Another question, how about f of 3.1? So just a little bit bigger than 3, where should that go? Okay, well 3 is the broken point here. So if you're just a little bit bigger than 3, technically you should be in the purple here. So if you plug in 3.1, that's like into the y equals 1 line. So if x is 3.1, we'll say it's right here. What does y equal? It's in this line. So y would just have to be 1. So that y equals 1 line, that says no matter what x equals on this interval between 3 and 5, whether it's 3.1 or whatever it is, y is going to be 1. Last one here, what's f of 7? So when you plug in 7, where should you go? Looks like it would be in the green here, on the green line. And x is greater than or equal to 5, so 7 would be right to put into this piece. So 7 plus 1, looks like we're at 7, 8, so 8 for that piece. So this piece right here, these f of any different value, that's just checking to see if you know where to plug each value in correctly into each piece of the function based on whatever these domains are. All right, let's look at example 2. I'm going to start by just giving you a couple pieces of the function. So I'm not even going to mark these axes. I'm just going to give you a couple line pieces. They'll be approximately, they'll be okay, you'll see. So there's a close end, there's an open end, and then here's the coordinates. So this one up here is at 1, 3.5, and this one's at 3, 2.5, so a little bit lower. And then the other piece, the other line here, 5, 1, and then 8, 7. Notice this one's got an arrow. And I want you to write the formula for the function. You know it's a piecewise function, it's got 2 pieces. I want you to write the formula for the function. So this piece has 2 endpoints. This one starts at 5, 1, and it goes through 8, 7, but it also has an arrow, so it looks like that points off to infinity. Okay, so let's write a formula for the function. So a couple things we can agree on. 1, there's 2 pieces here, and they're both lines. So we're going to find an equation for each line, and that'll help us, well, that'll give us our piecewise function. And just so we can keep things clear, let's call one of these line A and one of these line B. So the one on the left, that can be line A in purple. The one on the right, that can be line B. So let's take a look at line A first. Line A, let's find the slope. So 2.5 minus 3.5 over 3 minus 1 equals -1/2. I think I did that right. So the slope's -1/2. Again, these points aren't like completely accurate. I just kind of just sketched the lines in here. Doesn't really matter if it looks okay. And then so let's go. Let's put that into point slope form. So I'll use 3.5 and 1, and then simplify that. Slope intercept form. Y equals negative 1/2 x plus 4. So that's for line A. Let's do the same for line B. Get the slope. So for line B, let's get the slope. So 7 minus 1 over 8 minus 5. That's going to be 2. And then let's put it into point slope form again. So slope's 2, and I grab the easiest point I could find, which is 5, 1. I put it into point slope form. So then let's get slope intercept form. That's going to help us for our function. So simplify that, put it in slope intercept form. Y equals 2x minus 9. So these are our two pieces. Those are the equations of our two lines up there. So all we're given is this graph, and now we have these two lines. Okay, so let's use the notation for a piecewise function. So our function, how does that look? So f of x equals, and we have these big curly brackets again, right? So we have two pieces. So for the first line, line A, negative 1/2 x plus 4. Okay? Let's be really clear about what the domain is for that, though. So that's only for when x is between 1 and 3. So the domain is only for x is between 1 and 3. And that 3 is not included. So everything greater than or equal to 1 and just strictly less than 3. So everything greater than or equal to 1, but just less than 3. So that's the first piece. Second piece, and notice I'm not writing that y equals anymore. I shouldn't see any y's here anymore. I got f of x, that's like my y, and I broke it up. Right? There's no y equals in here. It's just negative 1/2 x plus 4, and this is just going to be 2x minus 9. There's no more y equals. So yours should look exactly like this. No y's. It's f of x equals, and it's these pieces right here. That piece and that piece for my function. Okay, so then what's the domain for this part B? The x values, it looks like it goes from 5 up to, well, this one's not, like this is a point it goes to, but that's not the ending point. So it starts at 5, but this arrow trending off to the right, that means it keeps going in this direction. So in terms of the x's, I would say it goes from 5 to infinity. So you could just say x greater than or equal to 5. Okay, so that's our first built function. We built our piecewise function, put it in function notation, just based on this graph alone. Got our two lines, got the equations, and we wrote it with the right notation and the right domains. All right, now it's time to talk about absolute values. So what is the definition, the true definition? You may or may not know it. You probably don't know it. The true definition of absolute value, like the function. I know it makes a V shape and it turns everything positive because it's a distance, but the true definition is this. So the absolute value of x is negative x when x is less than or equal to 0, and x when x is greater than 0. What does that mean? Well, let's sketch the graph. So I know it makes this V shape. So when we say negative x, that's really just like y equals negative x. So this line right here, or excuse me, this line right here, negative x would be this one. And y equals x for the other one. Y equals x would be this guy. So it's actually just the composition of two lines. One's positive, one's negative. And if we're really specific about the domains, like we only want the positive one when x is greater than 0. And we only want the negative one when x is less than or equal to 0. Okay? So, essentially it's two lines except for, what do you notice about the slopes? One's got slope 1, one's got slope negative 1. So, we know it's going to be V-shaped. We know it's V-shaped. So that also gives us opposite slopes. Just opposite slopes. I'm not talking about opposite reciprocals. I'm talking about just opposite, like they're signs, right? One's positive, one's negative. All right, so let's look at example 3 here. It's an absolute value graph, and I got it down to 5 here on the x-axis. 1, 2, 3, 4. This will be 5. So just an absolute value graph shifted right 5. So absolute value graph shifted right 5. And based on what I just gave you, you probably know what I'm going to ask you to do. So I know that you could write this as absolute value of x minus 5, let's say, but I'm going to ask you to write it as a piecewise function. So write as a piecewise function. Okay, so I know the function is just absolute value shifted right 5. So that's absolute value of x and then a minus 5 in there with the x. That shifts it right 5. But I want to break that up into 2 pieces. I'm going to write it as a piecewise function. So basically, I just need to use this x minus 5. I need a positive version of it, and I need a negative version of it. Those are 2 lines that come through there. So let's say A and B, I'm going to color code it. A and B. In green can be A, and then B can be the blue. So since A is negative, instead of x minus 5, I'm going to do negative x plus 5. Negative x plus 5. And you could think about that as just being the negative version of what's inside here in these absolute value bars. So that's the negative version. The positive version is much easier. You just write x minus 5. So for the negative guy, this negative x plus 5, what domain does it live on? Well, it looks like we only want that negative piece for everything from negative infinity up to 5. And then we shift and we want the positive line. So let's write that. X is less than 5. That's our domain. From negative infinity up to 5, you could just say x less than or equal to 5. Notice these are all inequalities, by the way, and not interval notation for this. Okay, and then for the positive piece, for B, that's literally just x minus 5, the positive version. And since this one got everything up to and including 5, the negative guy, A here, that got everything up to including 5, we'll just take everything bigger than 5, to be fair. We're not going to repeat 5. So we'll take everything bigger than 5. So it would be incorrect, I'll mark it in blue, it would be incorrect to say greater than or equal to 5, because then it would fail the vertical line test. It would hit 5 twice, actually. So this is the correct notation. Less than or equal to 5, and then greater than 5. Just like it says in the definition up here. X less than or equal to 0 or greater than 0. It doesn't hit 0 twice. So if you're doing an absolute value problem and you have to use the definition, literally all you have to do is take the negative version of this, negative x plus 5, or if you want to write it in the little side note in red there, and then take the positive version of that and just make sure the domain's correct. Alright, so let's look at our final example here. Example 4, it's a word problem. So Sarah has a job with a salary of $200 per week. And then she also earns a commission of 20% on weekly sales in excess of $1,000. So if she sells more than $1,000, she starts to earn 20% back in commission on those sales. So our goal, what we're going to do is we're going to express her salary as a piecewise function, because you can start to identify there's 2 pieces to that. So X is going to represent her weekly salary, or weekly sales in dollars. So we're going to write a function for her salary. We're going to call it S of X. S of X. X is the amount of money in her sales that she earns. So we already know we need this bracket here. Squirrely, curly, squiggly bracket, because we're going to have 2 pieces. So one piece is pretty simple. She gets $200 per week just on her commission. Say she doesn't, without commission, say she doesn't sell a single thing, she gets $200 per week. So it's just 200. 200 for how much does she sell? Well, whether she sells $0 or she sells up to $1,000, she's going to make $200. So that's really nice that that her organization will pay her $200 for not selling a whole lot. So that's from 0 all the way up to 1,000. So that part's not too bad. $200. If she's a bad salesman, she sells between $0 and $1,000. They'll still cover her for $200. But then what about the second piece here? So when she starts to earn 20% on her sales. So let's set up an equation for that. We know 200 plus 0.2 times x minus 1,000. So her $200, that's her base, plus she'll get 20% for everything she sells more than $1,000. So maybe this is kind of weird. X minus 1,000. Why do we write it like that? Well, that piece is actually just representing the excess. So the sales beyond $1,000. So $200 are flat rate, plus she gets 20% of the sales beyond $1,000. So that's the excess. Okay, so we can simplify this. So that equals 200, distribute that 0.2, minus 0.2x minus 200. So those 200s cancel out, and she just gets 0.2x. So everything beyond $1,000, she earns 20% of the sales. That's exactly what this is. 0.2 of the sales, 0.2x. Okay, so instead of a question mark there, 0.2x for x is greater than 1,000. So everything up to $1,000 is 200, and then everything bigger than 1,000, she just gets 20% of what she sold, which will still work out to be a better deal than the $200. So this company, it like gives her an inclination to sell more than $1,000. Okay, that's all for these notes. So wrap it up. See you in class.